All right, we're going to go over chapters 9 and 10 today, primarily chapter 9. So in the book, I'm on page 407. As always, I have a folder out there on the P drive that's got about 6 or 7 programs that deal with structures in them. We're going to go over those in just a bit. So if you want to go out to the P drive for the class and copy the folder to your virtual desktop, that'd be a good place to start. So chapter 9 is entitled Structures and Unions. We're going to talk 99% on structures, 1% on a combination of unions and bit fields. And then chapter 10 is really, it's a very complex chapter because they talk about different ways that you can use different kinds of advanced data structures in C. So we'll look at that, but not spend a lot of time on it. So again, there is a folder out there on the P drive with today's date on it, and that folder right there, that folder has 1, 2, 3, 4, 5, 6 different programs in it, and we're going to go over each of those programs in turn in just a bit. All right, but first let's go over some of the material that's in the book. All right. In many other programming languages, a structure is known as a record. The difference between, in C, the difference between a structure and an array is an array must be the same kind of data. So you can have an array of ints, an array of doubles, whatever. But you can't mix and match data types in an array. You can mix and match data types inside of a structure. In fact, if you look at the example that's shown here on page 407, here they're creating a structure. All right? And you'll notice that it has both an integer and it's got a character in it. What they're doing there is they're creating a brand new data type. When you create a structure, in essence, that's what you're doing, is you're creating a new data type. So we're creating the equivalent of a record here that holds both an integer value and a suit value. Again, this is supposed to be done after a card. And what they're saying here is when you look on a card, you're going to have S for spades, C for clubs, D for diamonds, H for hearts. All right, so that'll be the suit. And there's pips that they have here, and I wasn't aware of this. I don't know if you are or not, but supposedly there's a number of dots up on the top of a card, and that the number of dots is equivalent to the value of the card itself. That's what they claim, at least. Now, there's different ways that you can do this, whether this is good or bad. All right? But if you take a look right here, this is on page 408, because there's a couple things I do want to mention. It's important enough to mention them. If you look right here in this example, they're saying struct card, same kind of thing they had before. Then after it, they're saying C1, C2, okay? That's not normally the way, that's normally not the way that you would create a structure like that. The way that you normally would have shown at the bottom of the page. The reason that you typically would not create a structure like this is what this is saying is, I've got a structure that's a type card, and I'm only going to have 2 variables of that type. More often than not, when you create this, you'll start to do what's shown on the bottom of the page here. You'll say Typedef Struct card. And again, if that confuses you, you're going to see a bunch of examples in just a couple minutes. All right? Now, when you start to work with structures, there's 2 ways that you actually work with the stuff that's in there. And you're going to see both right now. All right? So if we take a look, let's see. For instance, if we look in here, okay, we've got struct student. So a student has a last name, they have an ID, and they have a grade. And you notice that once we set those up, we're saying we're going to create what? We're going to create one variable of type student that's called temp, and an array of students that's called class, and there's 100 students in there. Does that make sense? All right. each student will have, at least can have, a last name, an ID, and a grade. The examples I did are pretty much based off of this one. Again, they're pretty simple. And notice that when you do this here, you've got the name of the structure variable dot, and then the name. So the name of the structure variable dot and the name of the structure field. Okay? There's two ways that you can refer to stuff in there, and that's one of the two ways. You're going to see the other one in just a second. Like I said, I gave plenty of examples so you can tell this. One thing I want to mention, and for some reason they don't mention it in the book, and I don't know why. When you're creating a structure like this right here, anytime you've got struct followed by something and then the curly braces, you can't initialize something in here. You cannot. All right, it is not legal. It's not permissible. So you couldn't have said, for example, char star last name equals double quote, double quote. You can't do something like that. You get an error message if you try. It's just not allowed. All right. So again, one way that you can access structure element members is with the period. All right. The other way is going to be with a new operator, and that typically has to do with if you pass a structure and you pass it with an ampersand and you use it inside of a function. All right. Then instead of using the period like you see here in the blue, you use a minus sign followed by a greater than sign. All right. And again, you're going to see an example or some examples of this shortly. All right. All right. In fact, there it is. Here, if you turn up to page 414, there is an example there in your book. Right here. There's nothing wrong with, as they're showing right here, having a blank space. So they've got, for example, here it says a blank space minus greater than blank space, etc. You normally don't see blank spaces in here. You cannot have a blank space in between the minus sign and the greater than sign. It just would confuse the system. It doesn't realize that it's one operator then. All right. Where this gets a little bit confusing is when you start working with this stuff, they give an example right here, and it's actually a pretty good example on the bottom of page 414. So what are they doing? They're saying struct student, and they're creating a bunch of different stuff in here, and then they're talking about different ways that you can actually use this with the period as opposed to with the pointer variable and what you get. All right. And what's really ugly is when they use this. This is legal right here, this third one down. For some reason, it's not letting me highlight all of it. But you've got the star P inside of parentheses dot student underscore ID. You can do that. So in other words, this one that you see right here, this, you can do this. I've never seen that in application code. Because this right here is equivalent to this right here. If you use the star P in parens, then you can use a period as opposed to using the minus followed by the greater than sign. All right, is there any advantage to doing that? No. Not only that, I'd say there's a disadvantage. It has to be in the parentheses, and that has to do with the precedence of all this stuff. If you don't put it in parentheses, or if you put the whole thing in parentheses instead of this in parentheses, it won't be correct. So it's very easy when you're working with this stuff to screw it up. Using structures with functions on page 416. As they mentioned there, in C, structures can be passed as arguments to functions and can be returned from them. Most important sentence possibly of the chapter. Please look. When a structure is passed as an argument to a function, it's passed by value. So if you just pass the name of the structure, you pass it by value. So you're passing a copy. Well, what if I want to change it? You can also pass it with an ampersand. Again, you're going to see some examples of this in just a couple minutes. All right. This typically, again, is how you would see this set up. Typedef Struct. Okay. So what you're doing right there is you are creating a brand new data type when you do this. And now when I create if I want to create an example of that type of data, I can say employee data, Eric, for example. And then it would have available to it a name, an ID, a department, a home address, and a salary. Okay? Again, we're gonna go through a bunch of examples of this in just a couple minutes. Now, where it gets confusing, if it isn't already, but where it gets confusing is you can have structures that have arrays of elements. You can have arrays of structures. You can have a structure, basically that has arrays inside of it, and you can have an array of those. So you get some really butt-ugly stuff when you're working with this. And I'm going to show you some examples of that in just a couple minutes. All right? Now, one thing, notice what the author talks about in here. A couple things that you can do with structures you can't do with an array. First of all, notice that line there that's in blue. I'm on page 418, right down to the bottom of the page. It says struct home address, previous address equals 0 in parens. What that basically does is it takes the entire array and it sets it to null at the beginning. So if you wanted to make sure that it was set to null, all right, before you started, that would be a way of doing it. All right, so again, that's a way of doing it. All right, there was something else, and whatever I wanted to tell you, whatever else kind of has just left me, so hopefully it'll come back again. All right. So they go through this example, and I'm not going to run through it with you, but it's playing a poker game. And you'll notice it's 3 or 4 pages. Again, like it, dislike it, whatever. But one of the reasons I picked this book is if you look starting on page 422, they break it down and they explain what's happening in the entire thing, in the entire poker program that's in here. All right? Now, we ran through that quickly, so we're going to spend more time going through the examples in just a couple minutes. All right? But before we do, I want to mention the other stuff that's discussed in the chapter. The first here is a union. Back in the days when memory was much more of a premium, or at a premium, than it is right now, a lot of times what people tried to do was you may have had a field, and that field may have held, for example, it might have held either an integer or a double, but it couldn't have held them both. All right? So when you're working with a union, what you're saying here with int or float, this union can hold either this int I or it can hold that float f. So what the system does is, since floats typically take up more space than an int, it sets aside that much memory. All right, but it's going to either hold an int or a float. It's not going to hold them both. All right, it'll hold one or the other. Now, is that big a thing? Well, with memory not being at such a premium today, no. You'll find that some programmers still use unions, but most don't, because there really isn't that much of a need to anymore. All right, and the last thing that's discussed in here is they talk about a bit field. And it says, an int or an unsigned member of a structure or a union can be declared to consist of a specified number of bits. All right, so why would you want to do that? The same kind of reason that you'd use a union, if you want to conserve on memory. And you know, for instance, that you've got this pips, that it'll never need more than 4 bits or 2 bits or whatever. You can set that up. Again, is that done that much? It is still done, but more often than not, it's done when people are working on system programs. So in other words, if they're writing the newest version of Linux, they would care about stuff like that. For application programs, I've never seen any of that stuff. All right, I was an application C programmer for 4 years. I never wrote a line where I used a union or I used a bit field. All right, and the last thing that is in here, and it is the last one, starting on 430, the author talks about an ADT, and that's what Chapter 10 is basically about. So we're going to finish this, go over, look at some examples, and then jump into Chapter 10. All right? So they mentioned that an ADT All right, it's an acronym for abstract data type. As it says, it's a data structure together with its operations. Okay, and so what's an example of an ADT? Well, an example of an ADT is a stack. All right, and a stack is what's called a last in, first out, or LIFO type of mechanism. And if you go, I don't know what that is. Well, as an example, if you walked over to the cafeteria, okay, and there were no trays and you wanted to have lunch, and all of a sudden the cafeteria worker went and he or she put a bunch of trays in there, pushed them down into that little spring mechanism, chances are you'd grab the top one and walk away. Now, we're not talking about what if it's dirty. I don't care about stuff like that. All right. But the last one that they put in is the first one that comes out. All right. And they start to show you there how you can use and how you can implement a stack. All right. As opposed to a stack, there's another ADT that's called a queue. And you all know what a queue is. If it's the first day of classes and I say, how many of you have your books? And no one raises their hand. And I say, how many of you are getting your books at the bookstore? And you all raise your hand. I said, fine, let's take a half an hour and go to the bookstore. So you all get over there. Eric gets there first. He gets in line first. So since he's the first person into line, he'll be the first person to be checked out. So as opposed to a stack, which is a LIFO or last in, first out structure, a queue is a FIFO or a first in, first out structure. All right, and if you think, well, who cares? This stuff is used a lot, and it's used even more than just in programming. I took an economics class, and we taught LIFO and FIFO almost the entire semester with the instructor that I had. All right, so those are a couple of examples, and there'll be some more examples of them in the next chapter. But before we go over those examples in the next chapter, I want to go over some of these code examples. I created these yesterday, so, well, I shouldn't say that. I created 4 of the 6, and I stole the other 2. All right? So if you did copy them over, they're in a folder with today's date on it, and it's called structures. And I'm going to bring up all 4 of these right now, and we're going to look at these one at a time here. So grades 0, grades 1, grades 2, and grades 3. All right? So here's the first example. It's really, really simple. All right? I'm creating a brand new data type that's of type struct student. You say, no, that new data type is of type student. Technically, no, it's of type struct student. All right? When I say Typedef Struct student, that means instead of saying all this stuff, if I want to create a variable of that type, I just say this, struct student. Okay? There's a lot of ways that you can create, that you can typedef stuff. For instance, for years, you'd see this. The original C didn't come with a built-in Boolean data type, so you made your own. That's how you did it. So now, anytime you created something of type Boolean, it could hold either this or it could hold this. And it is case sensitive. So if you didn't want it to be in uppercase, you wouldn't put it in uppercase. All right. So I'm saying right here, I'm creating a brand new data type. It's a structure, and it's got 4 different variables in it. It's got an ID, which is an integer, a name, which is a character array, which is a maximum of size 20, a number grade, which is an integer, and a letter grade, which is a character. And what I did basically was I set up the first 3 things, and then based on your letter grade, you've seen this kind of thing before, 90 and up is an A, 80 and up is a B, etc. But I did it in the guise of using structures. So in main here, and I put everything right there in main in this first example. So I set up struct student, and I put me in there. and I set my ID equal to 1. I copied in, I did a string copy, all right, and I did my name. Notice Jeff.ID, Jeff.name, Jeff.number grade. All right, and Jeff.letter grade that you'll see down here. So these things I hard-coded in. Then I came in and I said if Jeff.number grade is greater than or equal to 90, Jeff.letter grade is equal to A, etc. All right? This is about as simple as it gets because everything is right inside of main. So if you've got everything and you're using it right inside of the same function, normally the only thing that you're going to use is that dot up. All right? You won't use, so you'll use the name of the structure dot the name of the field. What you're going to see in many of the other examples is we're going to have the name and we're going to have it like that. Does that make sense? Yes.
When you're building your structure there, I seen that after your brackets you had a semicolon. Is that what you're supposed to do?
Yes, the question was this, okay? And the reason that you have to do that is, the question was this semicolon that's right here in line 10. Why do you need that? Because can I do this and see, can I say int x? No, I've got to say int x semicolon, and it's the same way. You're making a variable declaration right there, but what you're doing is you're creating a new variable type. So yes, it is mandatory, and since this is a block structure language, it has to be inside of curly braces. But yes, you do need to have the semicolon on the end. So like I said, this is about as simple as it gets. You'll notice that in every case, you got the name of the structure variable, dot, and then the name of the structure field, be it ID, or name, or number grade, or letter grade. All right? So if I come back through here, you can see what the output is. It's pretty much what you'd expect. All right, because I set the ID up to 1, I set the name up to Jeff Scott, I set the number grade up to 88. So is that greater than or equal to 90? No, so that gets skipped. Is it greater than or equal to 80? Yes. So that should be the letter grade, and it is. All right, again, a really simple example. As you guess, these get more difficult as you go on. Any questions on that example? Yes, sir.
If you wanted to set up a separate function to maybe check, many students' grades, how could we say struct that student, that number grade?
Okay, the question was, let me see if I'm answering your question. If you had a bunch of students, okay, then what we could have done up here is we could have said struct student, and I could have said students bracket 50 bracket, and then there's 50 students.
Well, what I mean is, like, if we made a separate function to check the letter grades of those students, could we say struct.student.number grade or struct student.number grade?
It actually depends. Okay. All right. It depends on whether you're doing reading or whether you're doing writing. All right. And see if I answer the question as we go on and look at these. Okay. All right. So that's the first one. Let's look at the second one here. So you'll notice here what I have, same exact beginning. This is the exact same thing right there. There's no difference, okay? But now I've got a main, and I added a thing in here that's called print structure info. All right? And you'll notice that when I passed it in there with an asterisk. And the reason I'm passing it with an asterisk is I'm still going to be figuring out the letter grades for each one of the individual students inside of the function. All right? In other words, when I get into here, I've got print structure info. So I'm printing the first 3, but before I print the next ones, then I've got to come in here and I've got to figure out what their grade is. Now, this isn't really exactly what you asked, but if you would taken this right here and called another function for it, all right, you'd have to be using the asterisk or the ampersand with it. All right. Now, if we had set up all this stuff right here, if we had set all this up, and so notice for every one of these, I'm copying in the ID, the name, and the number grade every single time, and there's 5 of them. All right? So every time I'm doing that, and then I'm calling print structure info. And again, if I left this off, if I left that ampersand off, I'd be passing it by value. So if I made a change, I wouldn't be changing the actual structure itself. I want to change the structure itself. Since I want to change the structure itself, I pass it with an ampersand. I show it here with an asterisk. All right? So if I didn't want to do it like this, I want you to understand this. I'm going to just, again, I wouldn't do this, but I just want you to see this. All right, I could have done it like this. So what I'm saying is lines 48 and 49 that you see in gray there, they're the same thing. And you need the parentheses in there. You need the parens in there because otherwise it applies the asterisk to everything. And you only want it to apply to student before you do the ID. All right. I've never seen an application code anybody do that, but there's nothing stopping you from doing it. All right. And the author even mentions that in the text. So I'm going to just comment this one out, and then let's go back and take a look. So again, just follow the code. So notice I've done a type def here, so that's a brand new type of data. All right. So I said struct student, and I said Jeff, Sandy, Taylor, Mackenzie, Chloe. That's everybody in my family. Instead of doing it like that, I could have made an array of 5 people, and we'll do that in just a bit. All right, but I made 5 different structure variables. Okay, and for each one of those structure variables, I copy in the ID, I copy in the name, I copy in the number grade, and then I call the routine that's called print structure info. But because I want to actually change one of those values, I pass it in with an ampersand. If I had come in here and said this, if I'd come in there and said Jeff dot letter grade equals B, then I could have called that and I could have passed it like this. And I would have used it with a dot in there all over the place. But I'm not doing it that way. All right? So I don't know if, like I said, I'm trying to answer your question, but by and large, it depends on the circumstance. All right, so we do it for Jeff, then for Sandy, then for Taylor, then for Mackenzie, then for Chloe. And let's just grab Jeff. So you set his ID, set his name, set his number grade, and then call print structure info, again, passing it with the ampersand, which means that we have to use it with the asterisk. And even though I put this after main, it still is always a good idea for you to come in and still prototype your function. Okay? Let me mention, too, that sometimes what you see, I'm just showing you a few things here. I'm going to grab this thing that you see right here, all that code right there, and I'm going to cut it. And I'm going to come in and I'm going to put in a new file. Okay? And I'm going to save this, and I'm going to save it there as students.h. Okay? You see what's in there. I think everybody gets what's in there. I just pulled that out. Now, if I want, why would I do that? Because now I can go through here and I can say pound include students.h. And a lot of times you'll see that in code, because that way, if I wanted to have other files that were going to depend on that student structure, since it's not defined in here, all they would have to do would be to pound include that file. Now, is there, other than that, there's no advantage to doing it. If I know this is all the only way I'm ever going to do it, all right, I'm only going to have this thing. I'm never going to have other files connected to this. I'm never going to do. Then you might as well do it the first way I showed it to you. But this, putting it in here like this, I'm going to save this. Let's go back to students.h. That's already been saved. So this was students 1. Cannot open source file. Students1.c, no such file or directory. Oh, that's because it's not, it's grades. CL grades1.c. All right, grades 1. And you see everybody's in there. I got a B, my wife got an A, daughter's got C's, D's, and F's. Funny how sometimes code can mimic real life. Yes?
In order to access that file, that H file you made,
Yes.
do you have to have it in the root of the directory, or is there any way to...
The question, okay, let me answer it. You tell me if I'm answering it, okay? If I wanted to put this into another file, I could put in there ... / whatever, if I wanted to do that, if that's what you're asking. Yes, you can end up putting that any place. In fact, we're going to start going through that this afternoon in the PHP class, because we're going to actually come through and start building different folders in there. All right. Does what I just did make sense? That's what I'm asking you. You can do it either way. There's absolutely nothing wrong with declaring it here, but by declaring it into another file like this, that way I'm making it available if I decide I'm going to write other programs and I want each of those programs to be able to access that structure. I could have done it like that at the beginning, and then I've got 4 grades programs. They could have all just pound included student.h. So you start to see the advantage of doing it once, and you're sure that they're going to be exactly identical because they're using the same exact code. All right, it's going to be a savings in code, but it's the same kind of thing as writing a function library. And that's sometimes what people end up doing too. All right, these header files, like stdio.h, string.h, what are those? Yeah, they're header files. What are they? What's inside of stdio.h? Yeah, your standard input-output functions. So if I wanted to create my own function library, I could do that. All right, and then I could come in here and call it function library.h and just pound include that in all my programs. So if I was constantly doing programs that were doing sorting or whatever, it would make no sense for me to constantly be rewriting the same routines over and over and over again. And that's a lot of times what you find in a lot of C files is the pound includes at the top gets so big. I mean, I've already seen these where there's hundreds of them. So some smart guy, and when I say this, I mean smart guy, what they do is they grab all 100 of those, put them in their own .h file, and then just pound include that one .h file. And that's totally legit to do that. And it really cleans up the code. So instead of having 100, of these at the beginning of the program, you've got one. All right.
Is that how data is shared a lot of times too?
That is one way that the data is shared, yeah. In fact, other things in there, like, we've talked a little bit about data types. I mentioned the word extern, which says that something is defined someplace else. All right, you might find that declaration for that variable inside of a header file. All right. Any questions on this particular example? All right. So here's the next one. So now you notice I've done the same thing, and I was watching TV and The Voice came on yesterday, so that's why you got Christina Aguilera, Gwen Stefani, Adam Levine, Pharrell. I don't know what Pharrell is. Is his last name Williams? I don't know. And Blake Shelton. And I don't particularly like Carson Daly, so I went and brought Christina Aguilera back. All right. I'd much rather look at her than Carson Daly anytime. All right. So you'll notice that much of it looks the same, except in this case, instead of having 5 different variables like we had before, where I put Jeff, comma, Sandy, comma, Taylor, comma, Mackenzie, comma, Chloe, now I'm using an array. And quite often when you see these set up like this, they'll be set up singular. So when you set up an array, it'll be plural. Now, I've also seen books where they say you set these up plural and you make the array singular. All right. The only thing about a lot of programming languages is you can't get people to agree on stuff. But what I wanted you to get out of this was take a look how it changes. The name of the array, dot. And once we get into here, all right, I'm still passing what? A pointer to the structure. So that's still, this one looks the same. All right. But when we're filling the stuff up, since we're using an array, I hard-coded this, and this, and this, and this, etc. But I started to do that, and the reason that I did it that way was just to show you that when you start to mix and intersperse arrays with structures, you can combine the bracket and the dot. And sometimes it gets really complex. You know, you'll have bracket dot something, etc. I didn't even get into this, but let's suppose that I'm going to come in and I'm just going to put it on the board. So let's suppose that I'm going to go in and I'm going to create a structure. And so I say Typedef Struct. And I come in and I say, char star f name 20 char star L name, I should make these lowercase, L name 20. And I'm not going to keep going, but let's say that I had address, city, state, and zip. Okay? Everybody, I think, is cool with that. Well, there's nothing to stop me from up above here creating another structure up here that I call address and putting street address, city, state, and zip in it. And then what I can do is I can include here, so let's say that I came in here and I said, so that it'd have to be above it, so I said Typedef Struct, and I come in here and I say char star street address, we'll make it 30, char star city, and we'll make that 25, char star state, we'll just make that 2, supposing we have an abbreviation in there, and char star zip, we'll make that 10. All right, and I come in here and I say, let's just call it CSZ, city, state, zip, or street, city, state, zip. So now I can come in here and I can say struct SCSZ, and I can give it a name. Your address. And all I'm trying to show you is I can have a structure inside of a structure. And if I started to go in there and reference those individual members, sometimes you can get the name of a structure, dot, the name of a structure, dot, and you can have arrays interspersed in there also. Yes?
That's just the organized code? So
Yes. Yeah, and the question was, is that just an organized code? Yes. I mean, I could put everything in here, but if I have 15 different things, the structure gets a little bit unwieldy to look at. Some people like to break it up, and they might even, for example, they might have a structure called name, where they put in first name, middle initial, last name, and then another one that's got this information. See what I'm saying? And then maybe another one that was called emails, where you could put in a work and a phone email, or work and a home email rather, and then maybe numbers, landline number if you have one, and a mobile number kind of thing. So we could create 4 or 5 different structures up here, and then create another structure that held each one of those. All right, yeah, but that's basically, that is what it's done for.
And you could even further do that with files and organizing more.
Yeah, yes. And again, you can have structures within structures within structures. The only thing is C gets a little confused. If I would take this and define it after this, it would get confused, because it does go through in a lockstep order, and what it doesn't do by default is it doesn't do a lot of forward referencing. So it doesn't say, oh, that's probably defined someplace else later on in my program. So the suggestion is, really it's pretty much a requirement, is that anything that you're going to use in here that you're creating outside of here, created up above it. All right. But again, that's another thing that we could put in those header files if we wanted to do that. And again, if I run this one, what is it, 2? Pretty much the same stuff that you saw before. And actually, this was a commercial I saw for The Voice. I didn't watch it, but I was freaked out because on the commercial, Adam Levine shaved his head. Yeah, he just has little nubs up there. He still has more hair on the top of his head than I do, even though he shaved it. All right. All right, so let's take a look at the last one here. Again, Eric, this isn't what you asked, but in this example, rather than, you were setting up our structure, but rather than coming in here and hard coding anything, now what we're doing is we're allowing you to input the information for each student. All right, and then when you get done, we're printing the information for each student. But you'll notice, again, I'm asking for their ID, their name, and their letter grade. I'm asking for their ID, their name, and their number grade. I'm not asking for their letter grade because I'm still figuring that out. I thought I was. There, in here. So after I read it in, then I'm figuring out what that stuff is. All right. And you'll notice, since I'm working with everything in here, there's my array. There's my structure, which is an array of 5 students. But since I'm doing everything inside of this routine, all right, and you might look at this and go, wait, you didn't pass the ampersand in here. It's an array. So I'm passing the array. When you pass an array, remember, if you look up on the screen here, very important that you realize this. All right, I'm going to comment both these lines out. But when I do this, and when I do this, what I'm actually doing is this. Oops. Because when you pass an array to a function, you're passing a pointer to the first array element. All right? So that would work just as well. And when you look in here, you'll notice I need the ampersand here, but notice I don't need it here. Why don't I need the ampersand in that example right there?
Is it because it's a char?
You're close. It's because it's a string. It's a char array. And that's already a pointer. So what C decided to do, good, bad, and different, doesn't matter. But they don't have an actual string data type. Strings are implemented as character arrays. And that's both a blessing and a curse. It's good because there's a lot of really good string functions. It's also good because you can handle each character in the array if you want to. So you can fill a string up a character at a time. That's also the curse, because if you fill it up a character at a time and you forget to put in the \0, the system doesn't put it in for you. Then it's not a string anymore. All right? You can run into all sorts of problems when you do that. So if you look at this example, what's different with this one, now notice when I type in grades 3, now it says enter the ID, 1. Enter the name, Jeff. Enter the grade. Of course he got 100. All right? Enter the name, 2. John. Now you got 99. All right. 3. Luke. Not Luck. Andrew Luck. Luke. And Luke didn't have that grade today, so he got an 80. All right. And of course, somebody has to bring up the rear. So, all right. So you notice when we look at this now, what do we have? All right. But the difference is, in this case, we were able to actually input the values. So I wanted to put one of those in there so you could at least see what was going on. I have not written your homework yet. I will have it written by Thursday, but what I'm going to ask you to do is to make some refinements to the loan amortization program, and you're going to include pointers, and you're going to include structures. That'll be the last program that you're going to have in C for the semester. Question?
Hey, this might be a little bit advanced, but are we able to set something up like that to send the information to a database?
Question was, can you set something like that up into a database? Yes. All right. What our book doesn't go into that, but what our book goes into is setting it into a file. All right. But yes.
And then you can choose more than 5.
Oh yeah, you
So
could,
then
yes, yes. In fact, what you'd probably do is you'd probably do something where you'd have a program that you'd write that would read through and find out the number of records you had. Then you would create an array of that size. Then you would go through, and with something like this though, if you're using a file that somebody's already created with millions of names, you're not reading anything in. I shouldn't say that. You're basically, you're not asking the user, what's your name, what's your, you're just grabbing all that information and working with it that way. So yeah, you can either read it from a database, write it to a file, read it from a file, write it to a file, read it from a database, write it from any of those combinations, or do it just on screen. All right. All right, let's.
Can you narrow it down to maybe all these?
To what?
Narrow it down to you want to get grade all B students.
Yeah, you could do that after you were done with this. Sure, we could decide we only wanted to print out students that had Bs. In fact, what we could do is, as we fill this thing up, we could grab each student's information and have an A array, a B array, a C array, a D array, and an F array. And we could put each name and grade and ID number in those particular arrays. Yeah. And then you could even throw that into a database. All right, so it's 8:52. Let's come back at 9:05, and I want to show you the other examples, which are much more complex than these two we just looked at, or these few we just looked at here.